Hi, welcome to our presentation. My name's Jesse.
I'm Sophie.
And I'm Estelle. We researched the 2017 eruption of Mount Agung.
So, the type of disaster was an explosive volcano located on the island of Bali in Indonesia. The volcano lasted for about a year, 9 months, from November 2017 to June 2019. To the right, there's a picture of the actual volcano eruption, and to the left, there's a map of where the Mount Agung volcano is located at in the island of Bali.
Mount Agung is located on the Indonesian island of Bali. Of the 13,000 islands that make up Indonesia, there are 78 active volcanoes. Indonesia is located along an upside-down U-shaped region called the Ring of Fire. This is the most seismically active region in the world, beginning in eastern Australia up to Alaska and then along the western coast of South America. And the image above shows a 3D map of Mount Agung and all of its surrounding volcanoes. And below is a zoomed-in diagram of Mount Agung, and the pink highlights the lava flow created from the eruption.
So what happened and the events of the disaster? The seismic unrest peaked in early October, and the volcano didn't actually erupt until November 21st. There were intense eruptions accompanied by lava effusions during the event. Smaller explosions and effusions continued until as late as June 2019 after the actual explosion. During the explosion, the Indonesian government issued an evacuation order for 100,000 people in northeast Bali. However, many of these people did not actually evacuate as they didn't understand the severity of the situation. On November 26, one of the biggest international airports in Bali was closed due to the layers of dark ash in the air from the explosion. This left many tourists stranded. The image on the bottom right shows many local villagers attempting to evacuate while the volcano is exploding in the background.
So the relationship between the tectonic setting and the type of disaster that it occurred, the volcano started off by a tectonic earthquake that was detected on the volcano since early August of 2017. After that, the intensity of the earthquake coming from the volcano kept increasing to stop in October, but it actually hit a second wave more violent, and a majority of activity began in late November. Agung had since had eruptions in January, June, July, and December of 2018, in January, February, March, April, May, and June of 2019. And as you can see in the picture below, this is how the earthquake starts from below the volcano.
The scientific relationship between the atmospheric/the climate conditions and the type of disaster that occurred were that the volcanic eruptions were caused by molten rock called magma rising to the surface, and this pressure built up as the magma rose, and when the pressure got too intense, the eruption occurred. After the eruption of Mount Agung, it sent ash and gases like sulfur dioxide into the stratosphere. This caused global temperatures to cool for several years after. In the air, sulfur dioxide mixed with water droplets to create droplets called sulfate aerosols, and these small droplets reflected the sun's light away from the surface, and this led to a drop in temperature. And the diagram shows the sulfur dioxide concentration in Dobson units, and the closer to the center, the darker the red is, and the higher the units are. Figure A shows the area surrounding Mount Agung in eastern Bali. The volcanic features are shown by red triangles, the locations of the observatories are shown by green squares, and the relevant towns are shown by blue crosses. And figure B below it shows CVGHM hazard zones, and the red shows high hazard, the pink shows medium hazard, and the yellow shows a Lahar hazard.
So some general statistical facts was that the Mount Agung erupted 5 times in late November 17.
Additionally, the Indonesian government issued an evacuation order for 100,000 people living in northeast Bali during the explosion. Nearly 40,000 people were displaced in their country.
And the top of the ash cloud reached 12,605 feet above sea level on November 21st. And the eruption caused a decline of tourism in Bali by around 30%.
So, how this disaster has made a significant impact on human history and what we've learned from it. Many citizens were unaware of the warning systems before the explosion and did not know how to respond. This includes they didn't know whether to evacuate or not. They didn't know what the warning systems meant. The eruption of Mount Agung reinforced the importance of public communications during events like these. Therefore, after, there have been many changes in Indonesia in response to what happened during the explosion. This includes maintaining resources for evacuation, community training, and limiting population and living in hazard zones, in addition to expansion of these hazard zones. The image on the right shows a villager attempting to escape while the volcano is exploding, and the image on the left is a graph which shows the basic studies of volcanoes along with effective communications that governments can put into action in order to limit the disasters that come with these volcanoes.
So some of the history of the Mount Agung eruption was that the first eruption of the Mount Agung volcano started in February of 1963. The volcano started off with viscous lava flow that traveled down the side of the volcano, and within 20 days, the lava traveled about 7 kilometers in an elevation of 510 meters above sea level. The Agung volcano is the highest point of the Bali island, taking control of the areas around it and also influencing their climate. The volcano attracts the clouds that come from the west, and it also takes their water that makes the west side of Bali a very green and rich place, but leaves the east side of Bali a very dry place. The volcano is still active after the first eruption of 1963. It has a large and deep crater which sometimes emits smoke and ash, and from distance the mountain appears to be completely conical, despite the existence of the large crater.
So here we can see a difference between how some of the villagers evacuated versus the tourists. As I said previously, the international airport was closed due to the dark ash in the air. So on the left we can see pictures of tourists escaping on a boat. However, on the right we can see an image of villagers attempting to evacuate. This shows them gathering at what used to be a sports hall, using it as an evacuation center. Tens of thousands had already fled their homes around the volcano. You can see how crowded it looks and the disparity between the two evacuation routes. Some more photos. On the left we can see 2 villagers watching the explosion. This image really captures how the villagers didn't understand the severity of the volcano explosion and how important it is for the government to communicate what the volcano explosion really means. On the right we can see Balinese Hindu villagers at a local ceremony to pray for the end of the volcano. Ceremonies like these are really common in Bali, and they were very important during this situation.
And what can we expect next? Magma Indonesia has been monitoring and updating residents on Mount Agung over the past few months, and this volcano monitoring center has predicted that based off the 1963 eruption, that Mount Agung could have pyroclastic and lava flows, ash falls, and mudslides. And the University of Pittsburgh volcanoist Janine Kipner predicted that around 1.6 meters of ashfall could coat everything within 9 miles of Mount Agung's summit. And these are the sources that we used for our presentation.
Thank you for listening to our